Assalamualaikum viewers, welcome to my YouTube channel. I'm Bilal Academy. My name is Bilal, and in the previous video we have discussed about the mathematical relations which are used to calculate the frictional head loss, efficiency and the power of the pump, and how to do the optimization. So in this video I will do all the calculation in the Excel file, and I will make a graph as well for the optimization. So if you are new at my channel, then do subscribe to my YouTube channel and ring the bell icon so that you can get the notification of my upcoming video. So without wasting time, let's start the video. So let's say we have an elevation difference of 10 feet. First of all, converts the English units into the SI units. So I'm going to multiply the 10 by 0.3048, as we know that 1 feet is equal to 0.3048 and the pipeline length is 2000 feet, and just multiply the 2000 by 0.3048, you will get the answer in meters. And your volumetric flow rate is 200 gallon per minute, and convert this unit into the meter cube per second. So 1 gallon per minute is equal to 6.31 multiplied by 10 raised to power minus 5 meter cube per second. So I will multiply this 200 by the factor. So 0.01 meter cube per second is the flow rate. Density of the water at the room temperature is 1000 kg per meter cube. Viscosity is 0.0089 pascal second. So mass flow rate can be calculated by using this formula, density into volumetric flow rate. I will just multiply these two terms. Use all of the terms in the SI units, and the roughness is given which is 0.40457, and a constant which is PP, which is $2 per inch of diameter into feet of length. So convert into the SI units. I will divide the 2 by 0.0254 and multiply it by 0.3048. I need the CC in 1 per year units, and as you know, we have to convert this HP into the watts. So I will multiply this factor, divide this factor by 745.7. So I will get the answer in dollar per watt into year. So this is my given information. I will utilize this information in the mathematical correlations. Now I am heading towards the loss coefficient. So for calculating the head loss due to friction, we have to calculate the sigma KL, sum of the loss coefficient of every component. So in our system we have two globe valves, one check valve and two 90-degree standard elbows, one sudden expansion and one is the sudden contraction. So values of every component is given. You will just multiply the number with this loss coefficient, and you will drag it down for all of the components, and at the end you will just sum every term. You will get the sigma KL, which is equal to 17.64. I obtained the data for the pipes from the book, and for different nominal diameters I obtained the inside diameter. So you can see for the 2-inch nominal diameter, the inside diameter is 2.067 inch. So first of all, I will convert this inch into the meters. So for this purpose, I have to multiply it by 0.0254. So for calculating the area, I will use this formula, pi by 4 into inside diameter square. So this is the area which I have just calculated. So in order to calculate the average velocity of the fluid, I will divide the flow rate by the area. As the flow rate remains so constant, so I have to fix this cell. So I will press the F4 and divide by the area. This is the required velocity. So in order to calculate the Reynolds number, I will multiply the density of the fluid with the inside diameter and the velocity and divide it by the viscosity of the fluid. So this is the Reynolds number. As the Reynolds number is greater than 4000, so that's why we will use this formula for calculating the friction factor. As you know, the friction factor have this term, relative roughness. So for calculating the relative roughness, you will divide the roughness by the inside diameter. So roughness is given to us, which is 0.40457, and divided by the inside diameter. In order to calculate the friction factor, I will use this formula. So when you will put all of the required information in this formula, you will get the friction factor equal to 0.0337. Now I will show you how you will calculate the head loss due to the friction. So friction factor we have just calculated here, multiply it by the total length and divide by the inside diameter. Add sigma KL to this whole parameter and multiply whole of this by V square by 2G. So this is the V. You just take its square and divide it by 2 into G. G is 9.81 and then press OK. So it is the head loss due to friction 1.82 multiplied by 10 raised to power 7. So pump head is the sum of the elevation difference plus the head loss. So I will just sum these two terms. So this is the pump head. So in order to calculate the power, multiply the density. Density is 1000 kg per meter cube. Multiply by the density by the gravitational acceleration and the volumetric flow rate, which is constant. So I need to fix this cell as well, and the pump head. So you need to calculate the efficiency now. Divide the elevation difference as it is fixed. So I am pressing the 4 key and divide it by the same term plus the head loss due to friction. So the efficiency calculated is 1.67 into 10 raised to power minus 7. So purchase price can be calculated by the product of TP, diameter and the length. So the purchase price is 1.08 into 10 raised to power 3. For calculating the annual capital charge, multiply the CC. So CC is given information. Multiply the CC by the purchase price. So purchase price is this one. So it is equal to 4.3 into 10 raised to power 2. For calculating the annual pumping charge, just multiply the PC with the power. So PC is given to us. This is the power, and for PC it is given in the data. I have made a mistake here. I have not put the PC value. So let's put the PC value here. This is the PC value. So I'm going to just fix it up. So the annual pumping cost is 8.17 into 10 raised to power $8 per year. Let's assume that the maintenance cost is $1,000 per year. So the total cost will become equal to the sum of annual capital charge, pumping cost and the maintenance cost. So all of this calculation is for this nominal diameter 0.125. So we need to just drag this row for whole of the diameter. You will get the total cost for all of the diameters. So now we have the total cost for every nominal diameter. Now I will make a graph. So for plotting a graph, you will select the insert tab and select the chart. So first of all, I am going to plot the pumping cost with respect to the nominal diameter. So on the x-axis I have nominal diameter, and on the y-axis I will put the information of pumping cost. So now I will also plot the capital charge. So in the x-axis I will put again the nominal diameter, and on the y-axis I will put the capital charge. Now I will plot the maintenance cost. So I will again select the nominal diameter. So this is for the maintenance cost, and in the end I will also plot the total cost with respect to the nominal diameter. So this is the graph I have made. Let me zoom it on. So it is not clear to you. Let me change its axis. So as you can see here, there is a dip in the total cost here, and it is at the diameter point of 3.5. Let me simplify it for you. So as you can see, it is in between 3 and 4, so it is 3.5. So this is the most optimized diameter. At this diameter, you will get the minimum cost. So here I will end this video. If you like this video, then do subscribe to my channel and ring the bell icon so that you can get the notification for my upcoming video. Allah Hafiz.